A very good welcome to all of you. Today we are going to study sulfuric acid, syllabus ICSE, class 10, chemistry. Now, regarding sulfuric acid, we all know about its molecular formula. Molecular mass is 98. The structure, it is a structure that is of more importance to us. If we consider the structure, we could see that sulfuric acid is consisting of two hydroxyl molecules and one sulfur along with two oxygen bonds that are coordinately bonded to the sulfur. If we continue, we will say that sulfuric acid is mostly used in many industries, and only for that reason it is known as the king of the chemicals. In the Middle Ages, when green vitriol was heated, then we got an oily substance, and for that reason it is known as oil of vitriol. The reaction is something like this. When you heat green vitriol, ferrous sulfate 7H2O, it converts to ferric oxide, sulfur dioxide and sulfur trioxide along with water. So this will come out as a syrupy substance consisting of sulfuric acid. In free state it is rarely available, but in combined state it is available in many forms. For example, we have barytes, barium sulfate, gypsum, calcium sulfate and kieserite, magnesium sulfate. These are the sulfate ores that we can get. Preparation of sulfuric acid, there are mainly there is mainly one method, but we can have more methods to prepare sulfuric acid also. Here the book points that we can take sulfur dioxide gas, make it react with water along with oxygen to get sulfuric acid. We can make use of chlorine and bromine also while we allow sulfur dioxide to react with water, and in that case we will be getting sulfuric acid along with these two acids. But remember, separation of hydrochloric acid or hydrobromic acid from a mixture of sulfuric acid is difficult, so this is not a good idea to prepare sulfuric acid. Okay, if we take sulfur, we can make sulfur react with nitric acid to form sulfuric acid, nitrogen dioxide and water. Remember, we saw this reaction when we studied nitric acid. Okay, there is another method. If we take sulfuryl chloride will react with water to form sulfuric acid and hydrochloric acid. So here we can get sulfuric acid, although HCl will accompany. Okay, now the main concentration of this chapter is in manufacture of sulfuric acid via the contact process. In the contact process we make use of a sulfide ore, or we can make use of sulfur. If we take sulfur, we will directly burn sulfur in oxygen to get sulfur dioxide, or we can take iron pyrites, make it react with oxygen to get ferric oxide and sulfur dioxide. These two are the processes by which we industrially prepare sulfur dioxide gas. Now, if we are using elemental sulfur or iron pyrites ore, then it is expected that there will be some impurities present in it. So in order to remove those impurities, purification of the gas is very important. Purification is done by various processes. It is important because if we don't purify it, it will damage our catalyst. I will come to this diagram when I complete the discussion about the reactions, then we will come to this diagram later. Okay, we can use electrostatic precipitator. This electrostatic precipitator will give us a way to remove particles. It has a specific mechanism. We use high voltage electric current in between two electrodes, and as a result the particles are attracted to either of the electrodes. Okay, then we can pass it through water scrubber, that is a shower of water, and in that case it will take up the particles that is present in it. So this is also possible. We can send it to a arsenic purifier. For purifying arsenic, we make use of other compounds that take up arsenic oxide. Okay, then the next stage is a conversion of sulfur dioxide to sulfur dioxide. It is a critical process. It takes lots of concentration. Here we allow sulfur dioxide to react with oxygen to form sulfur trioxide at 450 degrees Celsius temperature. 450 degrees Celsius temperature is the optimum temperature that is available here. Okay, we use vanadium pentoxide as a catalyst. We can also use platinum as a catalyst. It has better efficiency, but it is costly. So for that reason we use vanadium pentoxide as a catalyst for this reaction. Now since this reaction is highly exothermic, if we want start the reaction, then after that we do not need to heat it, and the temperature is maintained at 450 degrees Celsius, as I said earlier, to maintain the continuity of the reaction. Then after sulfur trioxide has been formed, it is then sent to a container where it mixes with sulfuric acid, and this sulfuric acid is about 98% concentrated sulfuric acid. It forms oleum or pyrosulfuric acid. This name is very important. You have to remember it. Oleum, also known as pyrosulfuric acid. Now after this, in a dilution tank, if we go to a dilution tank, this pyrosulfuric acid or oleum can be diluted with water to get sulfuric acid, and the amount of dilution can be varied by adding different amounts of water in it. So in this way we can prepare various concentrations of sulfuric acid from oleum itself. But we could have dissolved sulfur trioxide in water alone to form sulfuric acid, but this is not feasible because it is highly exothermic, and what happens is that it forms misty droplets of sulfuric acid, and it is not directly absorbed by water. It's very hard to collect it, so we don't mix sulfur trioxide directly to water. Now favorable conditions. Before I go to the favorable conditions, I should go to the diagram that I left before. This is the diagram, and this is of our concern now. Okay, we are burning iron pyrite is here, air is blown in. Okay, iron pyrite is burns, we have sulfur dioxide, air, we can also have steam. Then it is sent to a chamber where the gas rests for some time, dust particles settle down. After that it is sent to a scrubber, and specifically speaking it is water scrubber. In this water scrubber, water is coming from the top and gases are going up. So gas go up, and here in this region the gas comes in contact with water. This water removes the particulates that is present there. Now the gas that has reached here in this position is wet, and so we pass it again through a chamber where a sulfuric acid rain is maintained. So sulfuric acid comes from the top and the wet gas goes up. Here wet gas gets dries up, as sulfuric acid is a dehydrating agent. Then this gas is passed to a arsenic purifier, and this arsenic purifier purifies the gas from arsenic. Then it is sent to a testing box. Here Tyndall effect is used to monitor whether dust particles are present or not. Then after that we pass it through a contact tower. Here this sulfur trioxide gas is mixing with here sulfur dioxide gas is again oxidized to sulfur trioxide. Here in this chamber it is oxidized to sulfur trioxide. This sulfur trioxide is then fed to this tower where we maintain a supply of 98% sulfuric acid and we have liquid oleum at the bottom. So this is all about this diagram. I hope you will understand it, and the processes has been outlined in this chart, so I am not going through it. Okay, now favorable conditions. Favorable conditions, this reaction is exothermic, so the lower the temperature, the higher is expected to be the yield. This will sound a little irrational to you, but we have Le Chatelier's principle, from which we can say that for an exothermic reaction, the lower the temperature, the higher is the yield. But and the higher the temperature, the lower is the yield. But if we decrease the temperature, then the rate of reaction is low. If we increase the temperature, then the rate of product formation is low. So that optimum temperature is maintained between 410 to 50 degrees Celsius. A pressure of 1 to 2 atmosphere is maintained. Here a volume contraction occurs, and for reactions according to Le Chatelier's principle, if the volume contraction occurs, then in a high pressure will favor the reaction. But giving high pressure, in order to give high pressure, we have to produce more mechanical energy, so we don't want to waste mechanical energy. 1 or 2 atmosphere pressure is enough. We maintain excess of oxygen so that sulfur dioxide forms converts to sulfur trioxide. This is the target. Suitable catalyst, I have already discussed about the catalyst. We use vanadium pentoxide. Platinum is a good catalyst, but as it is costly, so we don't use platinum. And platinum also gets poisoned by impurities like arsenic 3 oxide, so we use it. Now the summary. It's easy to maintain. Sulfur dioxide is formed from sulfur and oxygen. We can also form sulfur dioxide from iron pyrites. Then conversion of sulfur dioxide to sulfur trioxide. Sulfur dioxide reacts with oxygen to form sulfur trioxide. Remember the conditions: either vanadium pentoxide or platinum, temperature 400 to 450 degrees Celsius. Then sulfur trioxide is converted to oleum, and after that oleum is mixed with water to get sulfuric acid. So this is all about preparation of sulfuric acid. Thank you very much for watching. All the best.